Saxon Algebra 1, lesson 52. It's a two-parter today. Both will be algebra, no geometry floating into our lives at this moment. We're going to talk about denominators. Pesky denominators are so annoying because so often we have to adjust them, right? Here's an example. I don't like to talk too much. I'd rather just do a problem because I think it's easier to explain when you can see what the numbers are doing. We are told to add. And here's what we're adding. Now, here's an annoying fact of the day. When we see these two denominators, very often our instincts are, shoot, the x's match. Let's just add a plus y here and a plus y there, and then they'll be fine, right? Then they'll match. We can't do that. We can only change denominators. Does it surprise you that the first 5 letters almost spell demon? Demonators, denominators. We can only change them by multiplying. See my caps lock? That's because it's really important that you remember this. Okay? We can only change by multiplying. We cannot add a y to both of these. We can only do it by multiplying. That's why I like to call this new denominator that we're building, I like to call it the least common multiple. You can call it the least common denominator, but I like least common multiple because that M always reminds me, multiply, multiply, multiply. All I can do is multiply. So in this case, because I can't add an xy, all I can do is multiply the two denominators together. What the actual heck, right? That's the best we can do. And again, this is a situation where we have an expression. There's no equal sign, right? So all we can do is multiply these guys top and bottom by whatever pieces we want to get the new LCM as their denominator. So here we've already got the x. So I'm going to multiply this by x plus y and the bottom by x plus y. I'm using a different color just to help you see what I'm doing. I'm using the third rule of algebra. I'm using the numerator denominator same quantity rule, which says if you do want to change the denominator by multiplying, which we are allowed to do, we have to do it to the top two. It's only fair, right? It's like what goes on in most families with siblings. We all want it to be fair, right? Okay, over here, we've got x plus y, that's this. So what that means, I'm gonna put parentheses around it just so I don't get confused. I'm going to multiply it by x, and then I'll multiply this by x. Okay, so now we've done some adjusting. Let's write all of the adjustments out and see what we get. This top is going to be a times the quantity x plus y. I'm not going to distribute. I'm just going to leave it like this. Then it's going to be plus b times x. And now that the denominators match, we can just write it as one big thing, and it will be x times the quantity x plus y. This is a perfectly acceptable final answer. And both John and I choose to leave it in this form. What I want you to remember is that distributing or not distributing is neither good nor bad, right or wrong. Sometimes we do it, sometimes we don't, sometimes there's a reason, and I'll talk more about that as we go. But it's okay to leave it in this form. Now, this is where the solutions manual can become a little tricky. If you go to your solutions manual and you look at the answers here, this is a good example. This is not our problem, this is a different problem. But here we see John has something like this where he could have distributed that if he wanted. Here he didn't, but let's say that in your work you did choose to distribute that. And you come and look at this and go, well, is my answer wrong? Because John didn't distribute and I did. Here's the thing. It's never right or wrong. All you want to do is make sure that his would give the same answer if he did distribute. So you can see, oh, his would be YC plus YD. And if that's what you have, maybe the letters are reversed in each pair, that's okay. So you have to do a little bit of thinking to make sure that his answer really does match to yours, whether he distributes or not, and whether you distribute or not. Okay, so don't let the solutions guide freak you out. For this time, I'm gonna leave it this way. I'll do another problem and we'll try distributing the answer and see if that makes any difference. All right, let's try another one. 52.2. Here's our problem. As I copy this, I'm going to leave myself a goodly amount of room so that as I do my adjustments, I'm not cramming things into a tiny space. I want my numbers to have room to breathe. Okay, so I look at this. Those are my two denominators. I need an LCM that combines them by multiplying. We can only change the denominator by multiplying, so we can't, this wouldn't help us anyway though. This is going to be x times the quantity a plus b. That is our least common multiple. And so we'll multiply this one by x over x. And I like to put things in parentheses right away so that there won't be any messy confusion. And over here, we've already got the x, so we're going to multiply this one by a plus b. And again, I'm going to toss that into some parentheses so that it behaves itself. All right, now our denominators should be all set, right? They are both x times the quantity a plus b, which is exactly what our LCM is. Great. Now I'm going to do this undistributed. So I'm going to just write this in the order I like, though I like the x to be in the front. And then I can add it, because I know the denominators match, so I'm putting it all into one big thing. C times the quantity a plus b. And I know that's going to all go over the denominator of x times the quantity a plus b. This might be the answer, but what I'm going to do is I'm going to multiply it out and in the numerator and see if we get any like terms, because that is the one good reason to distribute, is that you might create some terms that match if you've got the same letters like this, right? We see there's an A on both sides. So it's possible that when you distribute, you might create some like terms that you could then combine. Let's try this one and see. So we'll get, ooh, this looks scary, 4x squared, don't let it worry you, plus, I'm gonna go alphabetical, ax. That'll make it easier for me to see any like terms if they exist. Okay, so I've distributed this, we're adding, and then we have AC plus BC. I don't see any like terms in any of that, so we're gonna leave our denominator undistributed. And I would say this is John's pattern, and it's my favorite way to do it. I like to distribute in the top to look for any like terms, and I leave the bottom undistributed. This is the answer the way I like it best. If you gave me this on a test, I would either say fabulous, full points, or if for some reason I thought it was important in that case, I might hand it back to you and say distribute your answer. All right, so you don't really have to worry about that. What really drives it is what else are you going to do with this number after you calculate it. Depending on what you do in a more sophisticated problem where there's a next step, it might make a difference whether this is distributed or not. Okay, that's enough talking about that. Let's try our next problem. There's one more problem like this, and then we switch. No, there's 4 right now. So we'll do 2 more. Ready? And then we have a slightly different topic, as I said. 52.3, add a plus b over x plus c over m. Okay, here comes the curveball. We get a floaty d. No floaties allowed in these problems. I immediately give it a denominator of 1. All right? Now this looks a little different, but the process is the same. We find our least common multiple, and we do that by multiplying these things together. I don't really have to worry about the 1, but here I see my least common multiple is mx. So now I want to multiply each one of these terms. See how I spread them out so I have room to work. I'm going to multiply whatever they need to be mx. Notice there's no equal sign in this. It's just an expression. So when we have no equal signs, that means the only way we can adjust is top to bottom. And we're not going to get rid of our denominators. We're just going to make them match. If we had an equal sign in this, it'd be a different story. But there's no equal sign, so be it, Jedi. All right, this first one, we need an m. This one, we need an x, right, to get our LCM in the end. X times m times x. This one just has a 1 down here, so that means we're going to have to multiply it by both parts. Make sense? And I'm going to be careful here, and I'm going to put parentheses on that because I don't want to get confused when I copy it over. Now I know my denominators all match, so I don't have to worry about them. My focus is going to be on the top. M times the quantity a plus b. Again, this m could sit back here, but I like it better to bring it to the front. Plus cx plus, and here I'll go alphabetical, dmx. And this is all over mx. John leaves it in this form. If you wanted to distribute this, you could, but I can quickly see that's going to give me an AM term and a BM term. That doesn't match anything I've got. So I can see right away, oh, there's no like terms. And I can call it a day for that little beastie boy. 52.4. It's roughly the same. I guess it's got a little bit more of a wrinkle. Here we go. A over. This is the part that catches my attention. It's minus. We're going to have to pay attention to that and make sure that doesn't mess us up. It's a floaty x, but I'm not going to write it as a floaty x. I'm going to put it over 1. Everybody's in the fraction club here. And then we're adding d plus m over x. We got quite the vegetable soup going on here, don't we? There's a lot going on. I notice that there's an x and a k. Those can get messy and easily confused. So I'm going to pay attention to that. I'm going to pay attention to that minus sign. And I'm going to pay attention to these quantities and get them in parentheses right away so I don't mess them up. All right, let's find an LCM for this insanity. This times this. This one's a 1, so it's not, doesn't matter. We don't have to worry about that. So our LCM is going to be k times the quantity b plus c. All right, again, we can only multiply them. We can't add. Let's do green. So now we're going to multiply each fraction, top and bottom, by the missing pieces. This one's k over k. This one, ooh, it's the whole thing. And this one, it's just this part. But I'm going to keep that like that. All right, I'm careful with my parentheses. All right. So now let's look at just the denominators. This is AK minus. Now sometimes this can feel scary. These guys are both on the outside of the parentheses. You can write them together. I'll go alphabetical. K times X times the quantity b plus c, right? So x and k are chilling together on the outside, and if we wanted to distribute, we distribute both of them. That just looks a little weird, but that's how you do it. This one, it's a plus. They both just stay in their quantity houses, and we call that good, all right? We're not going to distribute this one, so we'll leave it like that. And then the bottom will be k on the outside, b plus c, which is what our LCM is, right? We went to great trouble to get those all to match up. And that's the right answer. I'm just double checking because this is really long. Beautiful. Okay, so that's our work on expressions with rational expressions with denominators, where we have to adjust them to get them to match so we can combine them, right? We've been working on this style of problem for a while, and they're just slowly getting more and more and more complicated. We're not done yet. Spoilers. The second part of this lesson is a super useful calculation called the overall average. Let me read you a little story, and then I will tell you how it works. John does this as a formula. I do it differently. So if you look in the book, you'll see something different. All right, the average of the first 90 numbers was 4. Okay, so let's think about what we did. We took, oh, this is example 52.5. We took 90 numbers. I'm not going to write them down, but there was a whole bunch of them, right? There were 90 of them. We added them all up and we got a total. Then we divided that total by 90 because there were 90 items, right? And John tells us that the average of the first 4 numbers was 4. That means, and we're just filling in we're just imagining this diagram and getting all the information organized. We don't know yet what we're going to do with it, but we'll figure that out. This number must have been 360, right? Because when we divided it by 90, we got 4. So we can multiply to go backwards and calculate that number. Okay, so that's the first 90 numbers in this group of numbers we're talking about. The average of the next 10 numbers was 6. Okay, so we did it again. We took a bunch of numbers. There were 10 in all, not as many as last time. We added them all up. We got some total that we don't know yet. We divided it by 10 because that's how many objects there were. And the average was 6. So now we know that this total must have been 60, right? Because when we divided it by 10, we got 6. Okay, so now we know the first 90 numbers added up to 360. The second 10 numbers added up to 60. So what we can do is put this together, because John asks us what was the overall average. So what we're going to do is we're going to take these two sets of numbers and we're going to combine them. Now, when we add up all our numbers, there will be 90 plus 10 numbers, right? Because we're combining these two groups. When they are totaled, we know that there will be 420 right there, right? Because we added these, we can just add these two together. We calculated these before. John did not give us these numbers, but we figured these out for ourselves by working backwards through the average. So we know that the total adds up to 420. And I'll just write here 360 plus 60, okay? Let's make this 100. Now, to find the overall average, we're going to divide this by the total number of items, which is 100, to get an overall average of 4.2. The trick to these problems is to work through these diagrams and fill in this missing total. It's usually this number that we have to calculate, but we could find any one of these numbers if John gave us enough clues. So we figure out the totals of each subgroups, and then we combine them together and find the overall average. All right? This is a problem that is very confusing if you don't use this format to set up the information, right? Okay, I'm not going to say too much about that. If you have questions, be sure to ask me. And we're at the end of, you guys, we're already at the end of the first week back. What the actual heck? I didn't cross off 51, and now we're done with 52. Yay, all right? If you are a local student that works with me for video check-in, we'll be doing a review problem this week from lesson 49. And if you have any questions or feel like you're having a hard time getting back on track, be sure that we chat about that. Okay, that's all. Goodbye.